Hey, honors physics students, how about some hints regarding the Chapter 5 assignment? Let's start with number 83. These will be brief hints, but at least you'll be able to get started. What I'd like to do is give you an idea how to start on graph paper. So this isn't graph paper, but you should have graph paper for this assignment. These are adding vector problems. The first one is on number 83, you walk 30 meters south and then 30 meters east. And the displacement is the addition of both of those. So graphically, you're going to draw a vector, first of all, that's south. And so you would draw that to scale directly south. And then at that point, so that's your first vector. Then we're going to try another vector that goes directly east. So we start it from where the other one ends, and then you go directly east. Now, I didn't draw these to scale, but you should draw those to scale, and then the answer vector. We know the answer vector goes from the tail of the first to the head of the last, and so that's this vector. So certainly on your graph paper, you can measure that carefully, and in the same way, you could use trigonometry and the Pythagorean theorem to discover the answer. Remember this, the answer vector has a direction. So that direction is a certain number of degrees. You could call this a certain number of degrees east of south, or you could alternatively call this 90 minus that many degrees south of east. Let's look at number 84. Number 84 is about a hiking trip, and there are three segments. You should add those graphically for part A and for part B, but you are demonstrating the commutative property. So you should add all three of those vectors. And as you add those vectors, again, it's going to be graph paper. Your graph paper will have a coordinate axis. And you're going to add one that is 60 degrees north of east, 8 kilometers. So you measure 60 degrees north of east carefully. Then from that, you're going to add them head to tail. Another one that goes due east, 7. And so you start there and go due east. And then the third vector is going to go 4 kilometers at 315 clockwise from east. So imagine 315 degrees. We are imagining a new little coordinate axis right there. So if you go clockwise from east, if you go, counterclockwise from east, you start at east, that's 0 degrees, and 315 degrees. Well, understand, directly south is 270 degrees. So 315 degrees will be in here somewhere. And then the answer vector. Certainly that answer vector is this vector. Of course, I haven't drawn it to scale, but you can do this carefully with no trouble at all. Let's look quickly at number 85. Get back to the black, hopefully. Number 85 and number 86 are similar. So when you look at number 85 and number 86, these are both addition of force vectors. They're not subtraction, they're addition of force vectors. So on both of those, they are connected in the textbook tail to tail. You simply need to draw them head to tail. So for instance, in number 85 on your graph paper, you have a vector that's already drawn over here. That's 400 newtons. The other one should not start at the origin, but should start where this one finishes off, and so it should go that direction. So that's the vector. Of course, the answer goes from the tail of the head, the first to the head of the last. Both 85 and 86 are similarly started. Therefore, let's take a quick look at number 80. I'll let you work on 88 by yourself, but I'd like to take a quick look at number 89. Again, navigation. If you have all of these different displacement vectors, you should add them all together. When you add them all together, you are going to do this on a piece of graph paper, and as you do this on a piece of graph paper, add them. Draw one, then the next. The first thing is you draw a vector that's due east. So we start from the origin, go straight east, and stop there. The new vector starts there. It goes then 6 kilometers south. So you go from there 6 kilometers south, and you continue to combine these until you finally get an answer that goes from the tail of the first to the head of the last. Interestingly enough, the question does not. The question asks two things: how far are you away, And the other one is, which direction should you take to get back? The answer vector goes from the tail of the first to the head of the last. If you were only going 2 segments, that would be this. But they actually ask then for the opposite of that, because you'd have to take that to get back home. Hopefully these little hints have been of assistance to you.